and welcome to Tech presented by KYZEN, where we will explore common cleaning questions and answers. Let's get started. I would like to introduce KYZEN's own Raney.
Thank you, William. Today we'll be talking about cleaning inspection methods after the wash process. For this session, we'll be talking about the metal finishing industry. So here's a typical process of loading parts in the basket, washing, rinsing, and then it's followed by a dry step. The four most commonly used methods in the industry is black light, surface energy, gravimetric measurement, and particle counting. So to be able to perform the visual inspection with a black light, we need to have two of the three elements shown here. So we'll take a sample of the parts that were washed in a dark space. Once inside, we'll turn on a black light and proceed to inspect the parts. And with the help of the microscope, we can make a more precise inspection. In this image, you can see some parts covered with the oil which have not been washed. I just want you to pay attention to the inside geometries. Here we can observe the same parts using a black light, and we can see how the black light highlights the oil residues on the parts. These parts are after the wash process, and without any inspection method other than visual check, these look completely clean. But here, these pictures show the parts after and during the black light inspection. You can see some oil residue inside the part, though the outside of the part is completely clean, so don't be deceived. The visual inspection depends on the human factor. The parts look visually clean, however, they were not. And without the right tools, we can have errors during the inspection. If the inspection that is carried out is not correct, then the batch can be considered good, even though the parts are still not clean. And this can generate problems after the wash process. As an example, if one of these tubes is part of a subassembly to a welding process, the presence of oils in the joints will affect the weld. Causing this part would cause a failure and it'll produce scrap. Other than visual inspection with the black light, we have the surface energy test. To carry out these tests, we have two options. One uses a surface energy marker or pen, and the other one uses an ink bottle with an ear swab or Q-tip. Here we give the definition of surface energy with a few images as an illustration. In these pictures, we have a high, medium, and low surface energy. When talking about wetting, this is the ability of the ink to distribute itself on the surface of the parts. When you have good wetting, you can observe that the ink is distributed evenly on the surface, such as on the part on the left. The droplet is sort of flat and close to the surface of the part. On the other hand, when you don't have good wetting, you can see how the ink is distributed irregularly, and at the top of the ink is well above the surface of the piece as illustrated on the right. When talking about wetting, think of washing and waxing your car. When you just wash your car with soap and water, the water sheets instead of beads. Thus, it'll be clean. If you look at the copper coupon on the left part of the copper piece, it shows to be sheeting off, and on the right is beading up. The beading is like after you wax your car. So you leave residues, these residues are left on the part. In the case of the paint on the car, this is a good thing, but when you're talking about industrial parts cleaning, it's not a good thing. Here we can observe the behavior of the ink during the testing. In the first example on the left, we can see that there is a light layer of oil on the surface of our part. After the test, this indicates that the surface is contaminated, and our surface energy of the piece is less than the surface energy of the ink. In the second example, we can see that there is very light layer of oil on the surface of the metal. A moment after this test line is not complete. Small droplets begin to be generated, which indicates that the surface energy of our piece is not less than that of the ink. And then finally on the right, there is no layer of oil on the surface of our piece, and we can see that the line is uniform and unbroken. This means that the surface energy of the piece is greater than that or equal to that of the ink. You perform the surface energy test right on the part, but on the left, you can see that the line appears to be broken. It loses uniformity, which indicates that the surface energy at that point is less than that of the ink. The surface of the picture on the right shows a cutaway view of the solid line. That's this piece right here. So a solid line means that the surface energy is good and you got a clean part on the inside. For the surface energy cleanliness test, the ink must remain uniform for at least 2 seconds. And after 2 seconds, if there is no separation of the ink, then the test is a success. When talking ink versus the pen, each of these has its advantages and disadvantages. The marker is more practical because it's easier to use and fits in your pocket, though the surface energy ink requires a cotton swab for its application. For the ink, there is no risk of cross-contamination because you use a fresh Q-tip each time. The marker is easily contaminated with oil after a few uses, and it can be giving us false results. The tip of the marker must be completely clean before performing any test. So we talked about blacklight testing and surface energy testing for inspection. The next two methods are gravimetric and particle counting. The procedure is pretty similar for both of these. Once the parts are washed on the production line, the parts are taken to the lab where they'll be washed again to gather the impurities from them. The parts go into a lab washer, and the contents are left behind on the fluid. The inspection guidelines for gravimetric and particle counting in automotive, for example, can be found in ISO 16232. This applies to any manufacturer of automotive parts and talks about the cleanliness of automotive vehicle components and systems. In the process of gravimetric analysis, this is the process. You take a clean filter, place it in the oven, and you evaporate all the moisture that it may contain. Then the filter is cooled and weighed on a precision scale. Once this is done, we're going to use that same clean dry pad to filter the particulates that we captured after washing the part. This pad is placed into the oven again where it'll dry. It's then cooled and weighed again. The result is the initial weight subtracted from the final weight, and this is the weight of the particles filtered from the part. Even though this little chart is in Spanish, we can see an example of gravimetric analysis. The customer set the limit at 19.5 milligrams per 650 square centimeters. You can see that the resulting weight is 10.5 milligrams, so the test was successful. So we talked about blacklight inspection, surface energy testing, and gravimetric analysis. The last method of inspection is particle counting. Particle counting is similar to gravimetric analysis. You filter the particles through the filter, and it's placed into an equipment where the software inspects and determines the number of particles and their sizes. There are several microscope companies which offer particle counting analysis. The number of particles and their sizes are counted and then compared to a chart like the one pictured. Again, even though this is Spanish, this matrix is a good example. Here in this particle counting test on the right, we can see the particle size class and particle concentration class. The class size, designated by a letter, indicates the range it should be in. In this example, under letter B, the particle must be greater than 5 and less than 15 microns. In the first column, we see class 16, and according to the table on the right, must be between 32,000 and 64,000 of these particles. The customer generates the tolerances of the parts. In this example, the max number of particles is 75,539. At the bottom, we can see the results obtained, which were all zeros, which indicate that there were no particles counted on this part. So of the four methods of inspection, how can we determine which method to use? It depends on the process. For example, our goal is to clean a part in preparation of placing an adhesive label on it after washing, then you don't need to purchase expensive equipment such as a particle counter. But if you're talking automotive, then you want to utilize all the inspection methods. It's important to be able to determine if an inspection passes or fails. And this can be due to the washing issues such as cleaning time, chemistry concentration, and temperature. You can also check the arrangement of the parts for shadowing on those parts and review the geometry of the parts to determine the best fit during your wash process. In other words, make sure your parts are fixtured correctly in the wash system. Here are a few of the frequently asked questions on the cleanliness inspection methods after cleaning. Are the requirements of one cleaning customer in the automotive industry exactly the same as another? The answer is no. Each customer has its own requirements. Although governed by ISO guidelines, the requirements will vary from one company to the other. Next question is, if the surface energy ink fades after a few minutes, does that mean the test failed? And the answer is no. The ink should remain uniform for at least 2 seconds. After this time, it's normal for the ink to start fading or beating up. The last question is the cleaning on washing machines in a laboratory done with the same cleaning agent as the process washers? The answer is not necessarily. Each customer stipulates which agent is used to wash the parts in the lab. So that's all I have concerning the subject of cleaning inspection methods. I'd like to turn it over to William now. Thanks for your time.
Thanks, Wayne. Thank you guys for watching this Tech to Tech session. If you would like to discuss this topic further or have any questions that were not answered in the session, please contact your local KYZEN regional manager or send an email to tech@kaizen.com, and we will have someone follow up with you as soon as possible. And if you like this video, be sure to follow us on our social media platforms for more expert cleaning content.